Okay, and then I'm gonna share the screen. All right. Okay. Okay, here we are. Okay, perfect. So I'm gonna just probably click on the chat so I can see your messages right here. Okay, perfect. Now I can. Okay, so yeah, so we can start. So guys, I was saying, so this is still the same section, which is section 1.7, and again, it's about combination and the composition of functions. Thank you for the quick tip of functions. Okay, so well, so yesterday I see there are new to Mamadou, you're here. Thank you, Jillian. Okay, thank you guys. I got your name. Thank you. So yeah, so I was saying yesterday we saw how to do algebraic operations on functions, and again, what I mean by algebraic operations is the addition, subtraction, multiplication, and division, and so let me just first remind you the notation. So the notation here for the sum, for the subtraction, for multiplication and division. So first we had the first operation we had is a sum of two functions. So you write, f plus g of x, and what we mean by f plus g of x is f of x, of course, plus g of x. Next operation, next algebraic operation was of course, subtraction. So subtraction. And for the subtraction, so the notation is the following. So we had f minus g. So we write f minus g of x, and that means that will be f of x minus g of x. Okay. Next operation is the multiplication. Okay, and of course we use the dot for the multiplication, so it's like f dot g of x, and so that will be f of x times g of x. And the last operation was division, so operation number 4, so division, and we write like f over g when we divide functions. So it's like f, so it's f over g of x, and that will be f of x over g of x, right? Now, so I think we did a couple of examples yesterday on so how to do these operations on functions, and then I introduced the notion of common domain or intersection domain. So let me just remind you the notation for the common intersection or the intersection domain. So so let me just remind you here. So let's say so D subscript f, let's say that's the domain of f of x, right? And then let's say you have D subscript g, that's the domain of g of x, right? So then we denote by df with reversed capital U dg. So that will be the common domain to f and g, or the intersection domain. So this is the common domain, or if you prefer, the intersection domain of df and dg, intersection domain of df with dg, right? So again, be careful, guys, with the notation. So this is, so intersection is denoted by this reversed capital U. So this is that, this symbol here means intersection. That's the intersection between the two domains, right? Anyway, so so why we're interested in this intersection or this common domain? Because so as I mentioned yesterday at the end of the lecture, so because we are interested in the domain of f plus g, f minus g, f times g, and f over g. So we said so the domain of f plus g, f minus g, f times g, that will be the intersection or the common domain. So so as I mentioned yesterday, so we have the following theorem. So the domain of f plus g, f minus g, f times g is the common domain, is the intersection domain, is df intersected with the domain of g, right? So that's the intersection domain. And f for f over g, when you divide, well, we have like a special, it's a kind of special case. So for the domain of f over g would be the domain, the intersection domain, but you have to exclude the values where g is 0. So the domain of f over g is a common domain with the values where the values of x where g of x is 0 are excluded. So it is the intersection domain with values of values of g of x, values of x where g of x is 0 are excluded. Right. Okay, so well, so let me do an example. So here's an example. So let's say you want to find. So let's say you want to find. So find domain of f plus g, f minus g, f times g, and f over g, where, so let's say f of x is square root of let's say 2 minus x, right? And g of x is square root of 4 plus x. Okay. So you want to find the domain of f plus g, f minus g, f times g, and f over g. So here, guys, you don't have to compute you know, the exact expression of f plus g or f minus g, etc. Okay, because well, the theorem says the domain of this f plus g, etc., it would be the common domain. So all you have to do is, so the goal here is to find. So once you find the common domain, then that will be actually the domain of f plus g, f minus g, f times g. All right. So to answer this question, so all we have to do is we need to find. So we need to find the common domain, right? Okay. So once you find the common domain, then that will be the domain of f plus g, f minus g, f times g. For f over g, you have to exclude the values where g of x is 0. So how do we find this common domain? Well, as I explained yesterday, there are basically, let's say, 3 steps. So in step 1, you need to find the domain of f. In step 2, you need to find the domain of g, and in step 3, you can find domain of the common domain. So step 1, find domain of f, d subscript f. Domain of step 2, find domain of g, and then we can find the common domain. All right, so I'm gonna follow these steps, and that's how we're gonna find the common domain, right? So first step, step 1. So let's start with the domain of f. Of course, guys, I mean, if you have any questions, just please feel free to interrupt me, all right? So step 1. So in the first step, so we're gonna start with f. So my f of x is square root of 2 minus x, right? So guys, remember, I mean, if you want to find the domain of a function, well, there are two things you have to do. So if you have, if you have a division, so this is for the domain. So if you have a division, then all you have to do is you have to solve the bottom equal to 0, right? So here solve the bottom equal to 0, okay? And if you have a square root, okay, so if you have a square root, then you need to solve the expression under the square root larger or equal to 0, right? So like here in this function f, we don't have a division, which is good news. However, we have a square root, right? So if you have a square root, then all you have to do is to solve the expression under the square root larger or equal to 0. So under the square root, I have 2 minus x. So I need to solve 2 minus x larger or equal to 0, right? So we need to solve 2 minus x larger or equal to 0. Okay, so we solve for x. We can, we can add plus x both sides. So that would be 2 larger or equal to x. Okay, so here my x, 2 is larger than x. So in other words, x is less than 2, right? So in other words, x is less or equal to 2. Again, this is for, so this is less, all right, less or equal. And of course, this one here, this is larger or equal. Right? So what I'm saying is that the domain of f would be any number x less or equal to 2. And so on the number line, that will be, so you're gonna go from negative infinity to, to 2, right? So here's your number line, here's 2, here's negative infinity, positive infinity. So the domain of f would be like any number less than 2. So here's my domain, right? And of course, x can be equal to 2, so I'm going to include 2, right? So, so the domain of f would be negative infinity, which is always infinity, which is always excluded, and then 2, which is, of course, in this case, is included, right? So that's the domain of f. Now, next step, we said the step number 2. Step number 2 is to find, the domain of g, right? So let's find the domain of g. The step number 2. So my g is, where's g? G is square root of 4 plus x, right? So it's g is square root of 4 plus x. Okay. And we want to find the domain of g. Again, guys, we said there are two rules, right? If you have a division, then you need to solve the bottom is equal to 0. And if you have the square root, you need to solve the bottom of the what you have under the square root larger or equal to 0, right? So here under the square root, uh, we have 4 plus x, right? So this 4 plus x here, we need to solve for 4 plus x larger or equal to 0. Of course, if you have a number or something outside the square root, then you can just ignore it. I mean, you don't really care about it, right? So all you care about is the expression under the square root. So under the square root, I have 4 plus x. So we need to solve 4 plus x larger or equal to 0. I can, let's say, subtract 4. So my x would be larger or equal to negative 4. Okay, so like on the number line, here's negative 4, and my x would be any number larger than negative 4. Right, so it's going to be on the right side of negative 4. So domain of G would be, of course, domain of G would be like negative 4, positive infinity. Right? So I found domain of F, I found domain of G. Now I can find the common domain. So the step number 3, I'm gonna find the common domain or the intersection domain. So find df intersected with the domain of G, right? Yes, Leah, absolutely, is going to be negative 4, positive 2, but negative 4 and positive 2 both are actually included, okay? So unless you are an expert with this intersection, my advice is always use a number line. I think it would be more clear what will be the intersection if you use the number line. Anyway, so domain of F, it's negative infinity, positive 2. A domain of G is negative 4, positive infinity, right? So now let's find the intersection. Again, my advice is to use this number line. I need positive 2, so here's my positive 2. I need the negative 4. It's less than 2, so I'm going to put it on the left side of 2. Here's my negative infinity, positive infinity. Now let me draw the domain of F. So it's negative infinity to positive 2, right? Positive 2 included. And then that's the domain of F, the one in the red. Now I'm going to use the green for the domain of G. So it starts at negative 4 and it goes all the way to positive infinity. So that's the domain of G. Right. So then, as Leah said, so the intersection or the common domain would be this, from negative 4 to positive 2. Right. It's red and green at the same time. So that will be the common domain, or the intersection domain to F and G. So the answer here, df intersected with dg would be from negative 4 to positive 2, but you need to include actually both of them, right? Yeah, absolutely, yeah. So we have to include the negative.
I have a question though.
Yes, yes.
Um, for um for the first one, DF, um, why you oh here
Mhm.
layer two, why you change to less to equal to?
Less because you see here. So I started with the 2 minus x, right? That's my
Mm-hmm.
equation. 2 minus x larger than 0. I added
Mm-hmm.
x both sides, so then the minus x plus x cancel out, right? So you see here,
Mm-hmm.
I got 2 larger than x. Okay, so if you
Oh,
say,
oh, okay. Oh,
yeah, so if you say 2 is larger than x, it means that x is less than 2.
yeah, yeah. So that's why it's if okay, got it. Okay.
Mm-hmm,
Thank you. Okay.
you're welcome, sure. Um, yeah, so that's why we got this domain of f negative 2, positive 2. So we are not done yet because we didn't answer the question. So again, the question was to find the domain of f plus g, f minus g, f times g. and f over g. So then we can use this common domain to answer. Sorry. We can use this common domain to answer the question. So here's my answer. So the answer would be, so the domain of f plus g, f minus g, f times g is the intersection domain. So it's -4, +2. All right. We're almost done because there's also, we are interested in the domain of f over g, right? So now for f over g, okay, we need to exclude the values of x where g of x is 0. Okay, so we need to exclude where the values of x where g of x is 0. Okay, so we need to exclude the values of x where so g of x is 0. Okay, so I need to solve this g of x is 0 because, again, why do I need to exclude these values of x? It's because f over g, it means that you have to divide by g, and we are not allowed to divide by 0. So that's why I have to exclude those values. So g of x, g is, what is it? G is square root of 4 plus x. So I need to solve, we need to solve square root of 4 plus x equals to 0, right? Okay, so how do we solve such equation? Well, first, you need to get rid of the square root. So here's the square, both sides. Once you apply the square, you get rid of the square root on the left side. So this is going to be just 4 plus x, and 4 plus x, of course, equals to 0 square, which is 0. And so, of course, you just subtract 4. So then x is -4. So we need to exclude -4. So we need to exclude the x equal to -4. So you see, so then the answer for the domain of f over g, so then the answer, so the domain of f over g is, so you take, you see here, this is the domain of f plus g, f minus g, f times g. So the -4 here is included, right? Now for f over g, we need to exclude the -4. So it's gonna be, like, so here it's parentheses. So we're gonna have -4 and then 2. Of course, the 2 is included, right? So all you have to do is to exclude this -4. And that will be the answer for f over g, right? So that's the unique, actually that's the unique difference, right, between domain of f plus g, f minus g, and f times g, and the domain of f over g. Okay. Is there any question, guys?
Yes.
Mm-hmm.
Could you go over the part where, yeah, like right there, y is -4
2.
included? Yeah, d of g.
Uh-huh.
I don't
So
understand why isn't included and the positive infinity is excluded.
so you're asking about the d subscript g, the domain of g, this one here.
Yeah.
Okay, so that was in the step number 2 then, right?
Okay. Okay.
So I mean this, this and this step 3, right? I want to find this intersection between the domain of f and domain of g. So first, I have this domain of f. That's from the step 1.
Mm-hmm.
So you see, from the step 1, I got where's step 1? So here's my step 1. In the step 1, I got domain of f is -infinity, +2.
Right.
The infinity is always excluded because infinity is not a number. So we always, no matter what, we always exclude infinity, right? But
Okay.
then But then to find this, to find this domain of f, as I said, there are basically two operations you can do. So first, if you have a division, then you would solve the bottom is equal to 0. But if you have a square root, you have to solve what's under the square root larger or equal to 0. Like here for f of x, I have a square root of 2 minus x, right? So there's no division. I don't have to solve bottom is equal to 0. So there's no, because there's no division, but I do have a square root. So if you do have a square root, then you need to solve what's under the square root larger or equal to 0. So like here under the square root, I have I have this 2 minus x. So I had to solve 2 minus x larger or equal to 0 to solve for x, right? And once I solve for x, I got my x is actually less or equal to 2. And that's x less or equal to 2. That's why, so you see here on the number line, I got this interval here. That's where your number x is less than 2, right? I mean, it has to be on the left side of 2. So that's why.
The 2 is included because it's 2.
No, 2 is included because you see here, this is less or equal. So you see this line here, this one here, that means that x can be equal to 2. So here, this symbol here means x is less or equal to 2. So it can be equal to 2. So that's why I include the 2.
Okay. And it goes the same for the 4, I'm assuming.
Yes, that's the same thing here for the 4. For the negative 4, sorry. Yes, that's the same thing for the negative 4. It can be equal to the negative 4. So I include the negative 4. And then, of course,
I got that. That's all I wanted to know.
Okay, perfect. Okay.
Thank you.
Sure. Is there any other question, guys? Okay, so perfect. Well, so then I can give you probably a similar exercise. Again, guys, you need to keep in mind when you want to find the domain. I mean, it's not like you have a million things to do. Just check. If you have a division, solve the bottom is equal to 0. If you have a square root, solve what's under the square root larger or equal to 0. Then you get your domain, right? And then, etc. So, okay, so let's have an exercise. So here's an exercise. So you need to find, it's a similar question, same question, so exercise. So you need to find domain of, so f plus g, f minus g, f times g, f over g, where, right, so where, so first, f of x is, let's say, square root of, let's say x minus 1, or x, let's say x plus 2. Okay, and g of x is square root of 16 minus x, and then there is minus 4 outside the square root. All right. Number 2, f of x is, let's say it's equal to square root of x plus 1, and g of x is x plus 1 over square root of 9 minus x, and then minus 3. All right. Okay, guys. Sorry, I see there's a question in the chat. Idelize, you're saying where from the 2? So what do you mean? Do you mean this the domain of domain of f.
I mean the domain.
Domain of f.
The last one. The
The last
last.
one here.
Yeah.
Why I got why it's from the two here? Why I
Yeah.
got this two? Well, it's the two because, well, you see here in this on this number line, domain of f, we said it's so we agreed that the domain of f is negative infinity, positive two, right? So you see here, here's your negative infinity, right? And here's your positive two. So the positive two is included, right? Here's my positive two. And then you have the domain of g, which is from -4 to positive infinity. So it's like it goes from here, from -4 to all the way to positive infinity. So the intersection domain is the thing which is green and red at the same time, right? It's this interval here, right? This one here, right? It's green and red at the same time. So it's common to the domain of f and the domain of g, and it's from -4 to +2, right? And -4 and +2, they are included because they are included in the domain of f, and you see here it's included in the domain of g. So that's why I got this interval here. You see this one here? That's the common domain.
All right.
That's why I got the two. Does this answer your question? Not really.
Yeah.
Okay, perfect. Okay, guys, here's yeah. So I'm gonna give you probably 5 minutes, 5 or 10 minutes to think about this this exercise here. If you have any questions, of course, please. I'm here to answer answer your questions, of course. So Glenn, you're saying -2 positive infinity? Yes, for domain of f, step 1, yes. Kwame, you're saying 16 domain of g? Nope, actually, be careful. It's not 16 to positive infinity because, I mean, 16 to positive infinity, if you take 100, for example, 16 minus 100, that will be negative, right? So you cannot really have, and we cannot have a negative number, right? So under the square root. So it's not, actually, I think you, Kwame, I think you made a mistake with a sign. It's the other way, actually. So for domain of G, it should be negative infinity, positive 16. Oops.
For all right, never mind.
Mm-hmm. And again,
Wait, is the first one -2 positive infinity?
Yes, correct. It's -2 positive infinity. Yes.
Sir,
Mm-hmm.
under the f over g, when you're finding for g, do you include the -4?
Oh yes. Yes.
Oh, okay.
Mm-hmm. Yeah. So you wanna solve g equal to 0? Yes, you include the -4, of course. It's the whole g equal to 0. Yes. The problem number two, the g is kind of tricky. So just be careful. Number two, because in g, in the function g in the problem number two, you have at the same time we do have a division and the square root. So there are two things to do in the function g in the problem number two. So Glenn, you are saying 16 to negative infinity. Well, first, Glenn, for
I think it's the other way around. Wait, I think it's negative infinity 16.
yes. So you
Okay.
always go from the smallest, like the smallest number to
Yeah,
the
left
largest number.
to
Yes.
right. Okay,
Yeah,
yeah,
from
yeah.
left to right. Yes, it's always from left to right. But yes, let me see. So it's well. So you mean what do you mean by 16 negative infinity? That's the domain of G. Yes, right. Yes, Leah, that's correct answer for yes, absolutely for the common domain of the problem number one. Yes, it's correct. Mhm. Yes, Kwame. Yes, you have to solve the G equals to 0. Yes. Yes, yes, Samira, that's correct for number two for the domain of F. Yes, yes, it's correct. G of X. So let's see. You are saying so less than 9, and then yes, correct. Very good.
Professor,
Mhm.
for to find g over x, so we first gx equal to 0, right?
Yes, you have to
But
solve.
the whole, so we're taking the whole equation, like the whole equation, square root
The
15
whole,
minus 4.
yes, yes, the whole expression of G. Yes, yeah. So any guess for number 2? Yes, Samira. Yes, absolutely. That's the correct answer for the common domain for number 2. Yes, that's very good. Absolutely, yes. Number 2. Yes, yes, that would be the common domain for f and g. Yes, absolutely. The negative 216. Correct. Very good. All right, guys. I probably you are done with the exercise. Okay, so I will start with number 1. Let's say so here's so number 1. Okay, so step 1, domain of f. So f of x is square root of x plus 2. So there's no division. We do have a square root, so we have to solve what's under the square root, larger or equal to 0. So we have to solve x plus 2 larger or equal to 0. Okay, so subtract 2, then your x is going to be larger or equal to negative 2. Okay, so your domain would be any number x larger or equal to negative 2. So domain of f, if you draw your number line, so x has to be on the right side of negative 2. Negative 2 can be, x can be equal to negative 2. So we include the negative 2 because it can be equal to a negative 2, and then it goes all the way to positive infinity. Okay, so the first step. Second step, step number 2, we have to solve. So g of x is equal to square root of 16 minus x minus 4. That's my g of x, 16 minus x minus 4. And as I said, I don't care about what's outside the square root. Okay, you need to take the expression under the square root, which is 16 minus x. And so you have to solve 16 minus x larger than 0. So you have to solve 16 minus x larger or equal to 0. Okay, again.
I messed up. I thought it was 16 plus x minus 4.
Plus
I messed
minus.
up.
No,
Oh, yeah.
minus. Sorry, yeah. So it's 16 minus x larger or equal to 0. So I mean, we can, easiest way would be probably to add plus x to both sides. So that would be 16 larger or equal to positive x, right? So here you see 16 is larger than x, 16 is larger or equal to x, then in other words, x is less or equal to 16, right? That's the same thing, right? So your x is less or equal to 16. So on the number line, that will be any number. Yes.
So why didn't you add the minus 4?
Where? The g of x. Why I don't care about this minus 4?
Yeah.
Because the rule says that we are not allowed to have negative numbers under the square root, right? So the negative 4 is not under the square root, it's outside the square root, right? So that's why I don't care about this negative 4 here, because again the rule says we cannot have negative numbers under the square root, and -4 is not under the square root. All right, makes sense?
Okay.
So that's why I have just to solve this 16 minus x larger or equal to 0. Okay, and yes, so that's because of the rule. The rule says you don't care about what's outside the square root. You only have to solve what's under the square root, larger or equal to 0. And so your x is less than 16. So then your domain of G would be any number on the left side of 16, right? So it's negative infinity, which is always excluded. Infinity is always excluded, and then 16 included, because your x can be equal, you see here, can be equal to 16. All right, so we got the domain of f, we got the domain of G, so now we can find intersection domain. All right, so from the step one, domain of f, we said it's domain of f, we said it's -2 positive infinity. So -2 positive infinity. Domain of G is negative infinity, is positive 16. All right, so here's my number line. I'm gonna need -2, and I'm gonna need 16. So here's my negative infinity, positive infinity. Domain of f with the red, it goes from -2 all the way to positive infinity, right? That's my domain of f. And then domain of G is negative infinity to positive 16. So it's kind of similar to the example we had. So then the intersection domain would be this one here. That will be my intersection or common domain. All right, so then so domain of f intersected with the domain of G is -2, 16, and both are included, right? So now I can answer the question. So here's the answer. So then domain of f plus G, f minus G, f times G is this -2, 16. Okay, now there's f over G left, right? So now for domain of f over G, again, we have to exclude the values where G of x is 0. So we have to solve G of x is equal to 0. So G of x equal to 0. All right, and G of x is square root of 16 minus x minus 4. Okay, so here we have to solve G of x equal to 0. So now we have to take the whole expression, the whole equation of G, right? It's not just what's under the square root, but the whole thing, right? And so equal to 0 here, right? So we're going to solve this equation, of course. Can just add +4 both sides. So that will be, square root of 16 minus x equals to +4. Get rid of the square root now. So here's my square, and so that would be 16 minus x on the left side, and on the right side that would be 16. You can subtract 16. So then, So then my 16, my x, so then my x would be just equal to 0. My minus x is equal to 0. You can divide by -1 if you want. So there's -1 here, -1. So my x is just 0. Right, 0 over -1, of course, 0 over any non-zero number is 0. So we have to exclude x equal to 0. So this is to be excluded from the domain of from the common domain. So you see, so then the answer, would be so domain of f over G is, so you take the domain of the common domain, which is negative 2, 16. So here's my negative 2, 16, right? And then you exclude the 0. So I have to exclude the 0 from there, from the negative 2, 16. So domain of f over g is negative 2. So it's negative 2. So it's negative 2, right? And then I have to exclude 0. So here's 0 excluded. Negative 2, of course, is included. Union. And then I have to exclude again 0 to 4. All right, that's that 4. Sorry, 16. So to 16 here. And the 16 is included. Right. So I have a union of 2 intervals. So this is the union. So I have the union of 2 intervals, negative 2, 0, and then 0, 16. Again, guys, I mean, you need to think about, this like the interval negative 2, 0. I mean, between negative 2 and 0, there are an infinite number of numbers. So, you have like decimals, you have fractions between negative 2 and 0. It's not just a negative 1, right? You have infinite number of numbers between negative 2 and 0. So that's why, so you have to take all this interval negative 2, 0, right? So you have like, you have negative half, negative 0.75, etc. All those decimals are in this interval negative 2, 0, right? So we have 2 intervals here, the union of 2 intervals, and that will be the domain of f over g, right?
Professor, so why is it for the last one that we did with for the first example when the domain was negative 4 and 2, why there was no union? Was it because it was the
no,
x?
Yeah, that's a good question. That's a good point. That's because for the g is a little bit different. So here in this function g, there's this minus 4, right? Outside the square root. So you see this.
No, I'm saying for the first time you did it.
No, I understand your question. So you are saying why in the previous example we had, where is it? So in the previous example, we had only one interval, right?
Yeah.
We had this negative 4 and positive 2, right?
Yeah.
So that's what I'm saying. So you see here f and g, if you compare, if you compare this f and g, where's f and g? Here. So you see this f and g. So for the g, there's nothing here outside the square root, right? It's just the square root of 4 plus x. But for this example here, this one here, we have this minus 4. And that makes the difference, actually. That's why here we end up with the union of 2 intervals. Because when you solve g of x equal to 0, here, when we solve g of x equal to 0, we didn't get negative 2, or we didn't get negative 2 or 16. We got x equal to 0, right? Here we got, you see here, I got 0. I didn't get 16. So if I got 16, so imagine if I didn't have, you see, if I didn't have this minus 4. Imagine if I didn't have this minus 4 here, okay? So we're gonna solve square root of 16 minus x equal to 0, right? You put the square, then you're gonna have 16 minus x equal to 0. So then the solution would be x equal to 16. So what I'm saying is if g of x was just 16 minus x without the minus 4, then equal to 0, then the solution would be 16. And then I would have to exclude the 16. And if I had to exclude the 16, you see here, if I had to exclude the 16, then I will end up with one interval, right? I have just to exclude the 16, right? But here, because of the minus 4, I didn't get 16 as a solution, right? I got 0. And the 0, it's inside the interval. So that's why it's inside the interval. So that's why I have to split.
Okay.
I have to split my interval into like two different intervals. So that's why I end up with the union. You see what I'm saying? It's just because this minus 4, and so then the solution to g of x equal to 0 is 0 instead of 16. So, and this 0 is inside the interval. So that's why I have to split into the union of two intervals.
Okay.
Sure.
I understand. Thank you.
Any other question, guys? All right, so let's do the next next one. So let's probably move to the next page for number 2. So for number 2, so let's see, f is, where's f? Yeah, f is square root of x plus 1. So that's the first step. So let's do this quickly. So step 1, f of x is square root of x plus 1, or 1 plus x, x plus 1, sorry. So it's x plus 1. So again, this is just it's not a fraction. It's we have a square root, so we have to solve this x plus 1 larger than 0. You subtract 1. So then x is larger than -1. And so the domain of f would be any number larger than -1. So it's -1 included all the way to positive infinity. Now, step 2, for the domain of g. So here, domain of g, you need to be careful. So because your g is, it's x plus 1 over, so x plus 1. So x plus 1 over square root of 9 minus x minus 3. So here, guys, there are two things. First, g is a fraction. So we need to solve the bottom is equal to 0. And we do have a square root, which is square root of 9 minus x. All right, so we have to solve 9 minus x larger or equal to 0. So there are two things to solve. So first, solve 9 minus x larger than 0. Right, so then we're gonna add x. So then it's like 9 larger than x. So in other words, if you say 9 is larger than x, then x is less or equal to 9, right? So that's the first thing to solve, because we do have a square root, right? And then the second thing is you have to solve the bottom is equal to 0, because we have a fraction, right? So that's the first thing. The second thing to do is to solve the bottom is 0. And the bottom would be this whole thing here. So it's the square root of 9 minus x minus 3 is equal to 0. All right, so all right, so let's solve this equation. So here's plus 3 both sides. The square root of 9 minus x equal to positive 3. We use the square to get rid of the square root. And then that will be 9 minus x, sorry. So that would be 9 minus x. Come on. So 9 minus x equal to positive, equal to 9. 3 squared is 9. You subtract 9. Subtract 9 both sides. So then it's minus x equal to 0. And of course, you can just, divide by -1, let's say. So over -1 over -1. And so x would be just 0 over -1 is 0. So x is 0. So we have to exclude this value here. So this is to be excluded. That's where the bottom is 0. And we are not allowed to divide by 0. So that's we have to exclude this x equal to 0. So what we are saying here, we have two things, right? We have, we said x is less than 9 or equal to 9. And then we have to exclude this x equal to 0, right? So on my number line, so let's say here's, so here's 9 here, here's 0, negative infinity, positive infinity. So what I'm saying is my x has to be less or equal to 9. But of course, I have to exclude the x equal to 0. So I'm going to exclude this x equal to 0. right? So then the domain of G would be like negative infinity to 0, 0 excluded, union with 0, and then 9 included, because x can be equal to 9, right? So that's the domain of G. Now, you can move to the last step. So step 3, we're gonna find the intersection domain. So let me just write down the domain of f. So domain of f, we said it's just negative, domain of f is -1, positive infinity. So domain of f is -1, positive infinity, right? And then we have the domain of G from the step 2. And then, okay, so now I want to find the common domain. I'm gonna need, -1. I'm gonna need 0 and 9, right? So on the number line, I'm gonna have negative infinity here, positive infinity. So I'm gonna put my -1, and then I'm gonna put 0. Of course, 0 is on the right side of -1, and then I'm gonna put 9, which is also on the right side of 0. Now, domain of f would be this one here, from -1 to positive infinity. -1 is included, so that's the domain of f, right? And then the domain of G. Domain of G, it's negative infinity, and then 0 is excluded, and then from 0 to 9, 9 is included. Okay, so now the question is, what will be the common domain? What will be the domain which is, which is the intersection of the two domains? Well, that will be the domain which is at the same time red and green, right? So you see here, this interval here, it's red and green at the same time. Of course, we have to exclude 0 because 0 is not in the domain of G, right? So it's not common to f and g if it's not in the domain of G. -1 is included here, no problem. And the same for 9 here, it's also included, right? So the common domain in this case would be, so -1 included to 0 excluded, union 0 to +9 included. Okay. So we are almost done. Is there any question first, guys? I know that this G here a little bit tricky because there are two equations to solve, and that's because G in the function G we do have a fraction. So you solve the bottom is 0, and we do have a square root. So we have to solve what's under the square root larger or equal to 0, right? So yeah, so that's the common domain. So then we can answer at least the first part of the question. So we can answer, so the domain of f plus g, f minus g, f times g is, that will be the common domain. So it's -1, 0, 0 excluded, of course, 0, 9, 9 included. Okay, so now, of course, f of over g is left. So now, so for domain of f over g, so we need to exclude, f over g is a fraction, right? F over g is a fraction. So we have to exclude, or we have to solve the bottom is equal to 0. So the bottom here would be g, right? F over g. So the g, so we have to solve the g equal to 0. We have to solve the bottom is 0, which is g of x. So g of x is 0. So what's g of x? G of x is x plus 1 in the top, and in the bottom we have, I think, square root of 9 minus x minus 3 equals to 0. All right, so we have to solve this fraction equal to 0, right? The thing is, guys, when you solve the fraction is equal to 0, it means that the top is 0. Okay, because if the top is 0, 0 over any non-zero number would be 0. So whenever, so this is like a rule, okay? So it's like, so whenever I want to solve a fraction equal to 0, so fraction equals to 0, then all you have to do is to solve the top equal to 0. Okay, so I have to solve. So what we have to solve here is just x plus 1 equal to 0. X plus 1 is 0. You subtract 1, so your x is -1. So we have to exclude this -1 from the common domain. So this is to be excluded from the common domain. So you see here the common domain, guys. In the common domain, -1 is included, right? So now we have to exclude this -1. So now, so the answer would be, so the domain of f over g, oops. Okay, so the domain of f over g, domain of f over g is, so we're gonna exclude the -1. So there's parentheses, and then we have the same thing, of course. So 0, union 0, and 9 included. So the unique difference between the domain of f plus g, f minus g, f times g with the domain of f over g is the -1. So -1 is included in the first case, and then -1 is excluded from the second case. Any question, guys? All right, so so that's for the domain of f plus g, f minus g, etc. So I guess we can move now to the next operation. So the next operation is not, it's not algebraic operation. It's not addition or subtraction or whatever. So it's actually it's what we call composition of functions. So next operation. So I guess I can move to the next page. So next operation is composition of functions. So composition of functions. Okay, so let me explain with an example what do I mean by composition of functions. Okay, so example. So I'm going to start with some function f, some random, a random function f. So let's say f of x is, let's say it's just x squared minus 2x and plus 4, right? So the idea, guys, this is my function f. Now the idea is, well, I'm gonna play with this function f, and what I'm gonna do, I'm gonna replace the x by some function. So let's say I want to compute f of x squared. All right, so I decided to replace x by x squared. So instead of this x, so you see this x in here, and instead of x, I'm going to have x squared. All right, so what I'm going to do now to compute this f of x squared is to replace, so whenever you have x, you have to replace it by x squared. So you see here, you have this x in here, and you have another x in here, right? So you're going to replace each x by x squared. So we're going to have here x squared, and we're going to have an x squared here, all right? And then the rest is going to be the same. So we have a square here, so here's another square, minus 2, all right? And then there's a plus 4. Okay, so now guys, you should think of the circles, the blue circles, as parentheses. So this f of x squared is like x squared parentheses, and there's another square outside the parentheses, minus 2, then parentheses x squared, and then plus 4. All right. Now, guys, so this f of x squared would be x squared square. Remember the power rule. I mean, if you have like x a to the power b, that will be x to the power a times b. Okay, so x squared square, that would be x to the power 2 times 2, right? So this is x to the power 2 times 2 minus 2x squared and then plus 4. So final answer f of x squared is x to the fourth, x power 4 minus 2x squared plus 4. All right. So anyway, so the idea is, you obtain a new function. So this is a, this is a new function different from my f of x. So this is a new function here. Okay. So this new function actually is called the composition of f. So what I did is I composed f with not x, but with x squared. So this is what I call actually composition of two functions. So this is a composition of f with x squared. And actually, well, I mean, instead of x squared, I mean, you can pick any random function, right? So for example, let's say instead of x squared, let's say we have x plus 1, all right? So again, I have, and this is my f of x. We said it's x squared minus 2x plus 4. And instead of x, let's say I'm going to have x plus 1, right? So what I'm going to do, so the idea is the same, of course. So here's this x, the x becomes x plus 1. So this x here should be now x plus 1. The same here for this x plus 1, for this x, right? So it becomes x plus 1. So here I'm going to have x plus 1, and here x plus 1. And the rest is the same. Here's a square minus 2, x plus 1, then plus 4. And again, guys, it's very important to think of the circles like parentheses. So this is like, so my f of x plus 1 would be x parentheses x plus 1, and then square minus 2 parentheses x plus 1 plus 4, right? So you can distribute, I mean, this f of x plus 1 would be like x plus 1 times x plus 1, and then minus 2 times x, that's minus 2x, and then minus 2 times 1, that's minus 2, and then plus 4, right? And then you can distribute this thing here, x times x, then x times 1, and then you do the same with 1 times x, and then 1 times 1, all right? So let's distribute this thing. So we're gonna have, f of x plus 1 is gonna be like x times x, x squared, x times 1, that's x. Okay, now for 1, we have 1 times x, it's again x, and 1 times 1 is 1. There's minus 2x, minus 2 plus 4. Now I can simplify this thing here. X squared, I do have 1x squared here. So here's my x squared. Now the x's, so how many x's? We have an x in here, another x, that will be 2x, minus 2x. So 2x minus 2x, that will be 0x, right? So it's just, it cancel out. So this thing here, it cancel out.
Excuse me, Professor, it should
Yes.
be,
Excuse me?
should be plus 2.
Plus 2.
2 and plus 4, so.
No, because you distribute the sign. You see here, this is I guess you're talking about this minus, right?
Yes, minus 2 and plus 4.
No, so this is a minus because you see here minus and plus, you distribute the sign. So it's minus times a plus, that would be minus. And that's because of the parentheses.
Yes, but we can.
Oh, you see the final answer? The plus, oh yeah, but yeah, but yes, that's what I'm gonna do right now. So here plus 1 minus 2, because there is a plus 1 here, plus minus 2, so that will be negative 1, and negative 1 plus 4, that will be plus 3. So yes, you're right in some sense. So if this is a plus 2, then this is plus 1, so that's plus 3, right? So final answer, that would be plus 3. You're right. You can write +2 here. All right, but then you have another +1, so that would be +3. Anyway, so we're gonna end up with the same answer, right?
So
Mm-hmm.
the first example you gave, f
X
uh,
squared.
x squared. That one, do you solve it to the simplest form, or you're gonna leave it like that?
No, that's actually the simplest form. I mean, you cannot really simplify it here. It's just there's nothing here to simplify. I mean, x power 4 minus 2x squared plus 4. I mean, there's nothing to simplify here. All I have to do here is just to, multiply the powers right here. 2 times 2, x fourth, power 4. But otherwise, yeah, there is no real simplification here for the first example.
Are we allowed to simplify?
Oh,
Or
yeah. You need to simplify. Yeah, sure.
okay.
Oh, you have to simplify. Yes, absolutely. So that's what I did here in this example with x plus 1. You see, I mean, I distributed, and then I simplified. So yes, you have to simplify your answer, of course. And yeah, so anyway, so my point is, so we get this x squared plus 3, and so that's, of course, that's a new function. It's totally different from my original f of x. So this is a new function, of course. But anyway, so you see the idea here, guys, is that I composed two different functions here. So I have my f here, and I have my x plus 1. So what I did here, this is a composition of two functions of f and the function x plus 1. Okay, so that's what I call composition of two functions. All right, so let me write down the definition here for the composition of two functions. So what I'm saying is, so this is a notation. So let's say you have two functions. Daniela, you're saying y is plus 3. It's because there is a plus 1. You see right, sorry. So you see right here, there's this plus 1 here. So this is plus 1, and then you have this minus 2, and then the plus 4. So 1 minus 2, that's -1, and -1 plus 4, that would be plus 3. So that's why I got plus 3. That's because of this plus 1. And how I got this plus 1 is because you see here when I multiply 1 by 1. So that's why I got plus 1 there. Well, I hope that answers your question. Okay. I hope so. Okay, perfect. Then, so notation, guys, I was saying, so let's say you have two functions, at f of x and g of x. So here, x plus 1 or x squared. So I just picked some random function, right? Here I picked x plus 1. Here I picked, x squared, right? So you can pick just any random, any function g, right? So it's, so let's say you have two functions, f of x and g of x, be two functions. Then f composed with g. So then f composed with g. So this is the notation for composition. So this empty circle, that's it for composition. So f composed with g of x, that's f of g of x, right? So this symbol here, guys, means composition. So this is a composition. It's not multiplication, right? So you have to be careful. A dot, that would be multiplication. This empty circle or empty dot, that's composition, right? That's composition of two functions. So that's is the composition of f of x with the g of x, right? So for example, so that's the notation. So for example, an example here. Okay, so let's say f of x is x squared minus x, and g of x is 1 plus x. Or let's pick a different number. Let's say g of x is, yeah, let's say g of x is 1 plus x, all right? Okay, so let's say you want to compute f composed with g. And of course, you can also compose g with f, okay? So you want to compute, so in this example, I want to compute f composed with g and then g composed with f. So let's start with f composed with g. So we have f composed with g, right? So f composed with g, you see guys, first you have f. So f comes first, right? So f comes first. So I'm gonna write down f of x. So f of x is x squared minus x, right? Because again, f comes first, so I'm gonna write down f of x. And then I'm gonna write f composed with g of x. And we said this is supposed to be f of g of x, right? That's the definition. So what we have to do, guys, is you see this x in here is gonna be, the x becomes g of x. So whenever you have an x, like this x in here or this x in here, it becomes g of x. Okay, so this is my x, and now it's gonna be g of x in here, g of x in here. All right, there's a minus here, here's my minus, there's a square, so here's my square. All right, so that would be actually, so that would be, so let me write it here, f composed with g of x. So again, think of the green circles like a parentheses. So that's like parentheses g of x square minus parentheses g of x. Now, what's g of x? So we said g of x is 1 plus x, right? Here's my g of x, it's 1 plus x. So let's just replace g of x with 1 plus x. So here we're gonna have f composed with g of x. So we're gonna have 1 plus x squared minus 1 plus x. So again, guys, don't be shy. Please feel free to ask questions, all right? Now, I have to simplify this thing here. I can, I have to compute like 1 plus x squared. So it's like, it's like 1 plus x times 1 plus x. And then there's this minus 1 minus x, right? I distribute the sign. So that will be, so let's distribute 1 times 1, 1 times 1 times x, x times 1 is x. X times x, that will be x squared, right? We're gonna have 4 terms. And then we have minus 1 minus x. All right, so again, guys, just be careful with distribution. So 1 times 1, 1 times x, and then x times 1, x times x. So that's why I got 4 terms. Okay, then minus 1 minus x. So then I can just simplify. So find answer. Yes.
So the minus sign affects all the numbers on the right, right?
Oh yeah, of course. Here, oh yeah, of course. That's how you distribute the sign, because of the parentheses. So minus 1 and then minus times a plus, that will be minus. Yes, of course. And so then, well, here, let's see what happens to the constant. Here, 1 minus 1, so it cancel out. We have an x minus x, it cancel out. So we end up with only one x, this x here, and plus an x squared here. All right, so that will be a fine answer. I simplified my my equation, and I got this x plus x squared, right? So the 1 cancel out, the x cancel out, you are left with x and an x squared, and that's the final answer for f composed with g, right? Now, now what about g composed with f? So g composed with f, it means you start with g first. So we have like, so now I want to compute g composed with f, right, of x. So as I said, here g comes first. So what I'm going to do, I'm going to write down first g of x, which is just 1 plus x, right? And then I want to compute g composed with f, or in other words, g of f of x, right? So now what you have to do, guys, is you have to replace this x in here by f of x. So I only have one x in the function g, right? This one here. So this x here is going to be now f of x. So it's like we have 1 plus, and this x here becomes f of x, right? So then my g composed with f, it's 1 plus parentheses f of x. So so f of x is it's actually x squared minus x, right? This is my f of x squared minus x. So it's 1 plus x squared minus x. That's my f of x. And so then g composed with f is actually 1 plus x squared minus x. All right, you distribute the sign, plus x squared plus minus x, so it would be minus x. And that's the final answer here. I mean, you don't have any real simplification here, so that's the final answer. And of course, if you compare f composed with g, so if you compare these two things here, this thing here, that's the f composed with g, with the g composed with f, so there are different functions, right? Here it's x plus x squared, and here it's 1 plus x squared minus x. So there are two different functions, right? So that's in general, f composed with g is different from g composed with f, right? So in general, so that's like it's a general fact. So in general, f composed with g is not equal to g composed with f. So you get two different functions, all right? Is there any question, guys, about this composition? All right, so, okay, good. So then here's an exercise where we have to compute the composition of two functions. So exercise. So let's say f of x, and again, guys, you have to simplify your answer, okay? So let's say f of x is 8x over 1 minus x, and g of x is 3 over x, right? So please compute f composed with g and g composed with f. Again, guys, so if, for example, you want to compute f composed with g, so my advice is first write down f, okay? Write down f, and then you replace your x with the g of x. So yeah, so I'm gonna give you a couple of minutes, guys, to think about this exercise. So please try to find f composed with g and g composed with f. So I guess, I mean, we're gonna continue with this next time because we're gonna also use graphs, to find this composition of two functions. So we're gonna have more examples, but then the goal would be to find the domain of this f composed with g, right? So what I'm saying is this composition is like an operation on functions. And as we did for f plus g, f minus g, f times g, and f over g, we're gonna try to find the domain of f composed with g, right? So the goal next time would be to find the domain of this f composed with g, right? And before that, we're gonna also use graphs to find this f composed with the g of x. So tomorrow morning, guys, I will post the notes and the video, right? The lecture video on Blackboard of yesterday and today, right? And of course, with the homework number 4. So if you have a division, you have to divide. If you have multiplication, then you need to multiply. All right. So then you simplify your answer. Any guess for f composed with g? Yes, Samira, that's excellent. Yes, correct. Yeah, so guys, I guess you have to deal with division of fractions, subtraction of fractions. When you divide fractions, you have to flip the one in the bottom. So Samir, are you saying that's for Let's see. Yes, yes, very good, Samira. That's the correct answer. Yes. Did anyone else get the 24 over x minus 3 for the f composed with g? So yes. Oh, okay, perfect, Kwame. Very good then. Okay, perfect. Thank you, Elisa. All right. So, I mean, we have like 4 minutes, so we don't have much time. Anyway, I'm gonna come back to this next time. I mean, we're gonna continue with this composition next time. Okay, so let me go over this exercise in the last 4 minutes, and then we'll have, I guess, more examples next Monday. Right. So for f composed with g, so for f composed with g of x, right? So as I said, you have f first. So write down f. It's 8x over 1 minus x.
Hey, are you gonna do this again next week? The same problem?
Not the same problem. I'm gonna do it now, but I'm gonna have more problems next time, I guess. Well, or probably I'm gonna do it again next time. Yeah, I mean, if I don't finish, I guess I'm gonna do it next time. Okay, so I wrote f first. So this is my, because f composed with g, so we have f first, so that's my f of x. Now I can compute f of composed with g, which is by definition, so we have f first and then g of x. So you see, guys, what we have to do is to replace our x by g of x. And we do have two x's, right, in f. We have this x in here and this x in here, right? So we're going to have, this would be equal to 8. And then this x in here, so in the top is going to be now g of x, and there's an x in the bottom. So this would be now g of x. And in the bottom, we have 1 minus, and that will be also another g of x, right? So don't forget there are two x's, one in the bottom, one in the top, and both x's, you have to replace both x's by g of x. Okay, so then your f of g of x would be like 8 times, so 8 times g of x, which is 3 over x. So here's my 3 over x, right? That's the top. Now in the denominator, we have 1 minus, and then g of x, which is 3 over x. Okay. So there are two operations here, guys. First, in the top, we have multiplication. We have 8, which is a whole number.
Where did the 3 even come from?
The 3?
Yeah.
Yeah, that's because g of x is supposed to be 3 over x. You see here? That's your g. So
Okay.
it's 3 over x. So, so you see in here, I have, where is it? Here, this is a 3 over x, and this is supposed to be 3 over x. Okay. Now, in the top, I have multiplication. I have a whole number, 8 times the 3 over x. 3 over x is a fraction, right? So I need to write 8 as a fraction. So 8 is a whole number, but I mean, I can always divide the whole number by 1, right? 8 over 1 would be also 8, okay? So that's like 8 over 1 times 3 over x. So that's a multiplication of fractions, right? So it's just multiply straight across. So that's f. So this f of g of x would be like in the top 8 times 3, that's 24, and then 1 times x, it's x, right? So that's the top. Now in the bottom, we have 1 minus 3 over x. Again, 3 over x is a fraction, right? So what I have to do is to write 1 as a fraction too. So then we're gonna have like subtraction of 2 fractions. And how do we do the subtraction of fractions? We need to get the common denominator, right? So the common denominator would be, so here's the denominator is x, right? And here denominator is 1. So what you have to do is to multiply by x in here and to multiply by 1 here, times 1 times 1, right? So in the bottom, we're gonna have 1 times x is x over 1 times x is x, right? Common denominator, minus, and 3 times 1 is 1, and x times 1 is x, right? So again, guys, you need the common denominator, right? So now, so we have still this 24 over x in the top. Now in the bottom, since you have now a common denominator, then you can subtract the top and keep the same denominator. So if you subtract the top, so when I say the top here, right? So here, right? So we subtract x, so that will be x minus 3. And the denominator would be the same. You keep the same denominator, so which is x. So now I have division of 2 fractions. So how do we divide fractions? Well, you flip the 1 in the bottom. So it's like f of f composed of g of x. So it's going to be 24 over x, and then you flip this one here, right? So it's going to be like times, and you flip it, so it's x over x minus 3, right? So it's, it's 24, you multiply straight across, so 24x over x times x minus 3, right? So here you can simplify. There's an x in the top, there's an x in the bottom, so they cancel out. And so final answer would be, so f composed with g would be 24 over x minus 3, right? So that's the final answer. Okay, sorry guys, I went over time. So I would probably come back to this next time to do the G composed with F because we are not done yet, right? There's a G composed with F, and we'll have probably more examples next Monday. All right, so I'm gonna stop here, guys. I'm sorry I went over time. Please don't forget your homework. Number 3 is due today. We'll post the homework number 4 tomorrow, and I will see you then in the next.
I have question.
Yeah, sure.
About the homework number 2. I sent you the email yesterday, but you still don't fix it.
The homework number 2 about about the videos, right?
Yeah.
Oh yeah. And you didn't get your grade yet.
Yeah.
Oh, okay. So no problem. I will grade it. I mean, because I didn't have time yesterday, so okay. Yeah, I will grade it as soon as possible. Don't worry, Mama.
Okay, fine. Thank you so much. Have a good one.
You too. Thank you, guys. Take care and stay safe. Of course, I will see you next time on Monday. Right? Thank you. Thank you, guys.